Hello and welcome, I'm Tafarak Adamu. 2 years ago, the NASA mission known as Lucy, 12 years, 11 asteroids, and 1 spacecraft took off. Last month, Lucy encountered the main belt asteroid they call DINKINESH and its satellite, which is SELAM, both after the famed discoveries in human origins research in Ethiopia. Why have these encounters been named so? And what does that mission intend to achieve over those years? That and more with my guest, Hal Lavison, the mission's principal investigator. A very warm welcome.
Pleasure.
So tell me about this Lucy mission. How did it all start?
It started with the realization that we needed to have additional data when it comes to understanding how the outer solar system formed. So Lucy is a survey of a population of asteroids that we call Trojan asteroids. These lead or follow Jupiter in their orbit by about 60 degrees. Turns out that if you put an object 60 degrees from a big planet, the gravitational forces of the planet and the sun, plus the centrifugal force of rotation around the sun, cancel out. And so at these locations, Jupiter has the most of them, we find these populations of asteroids that are basically fossils of the planet formation. They were there as the planets formed, and they evolved, and they're now the leftovers of that process. So I'm actually a theorist by training. I study how planets like the Earth form. And Lucy came about by the realization that we were missing some important data to tell us about the history of the solar system, and the Trojans is the most likely place to go that will allow us to figure all that out.
So how many asteroids are we talking about here?
Well, it depends on what you mean, right? You mean in the Trojan?
The Trojan asteroid.
Yeah, there are tens of thousands of them, bigger than about a kilometer. There are a lot of them there.
So what are you aiming at? How many of these asteroids are you trying to cover in the next, how many, 11 years?
Yeah, it's 10 years from now. Okay. The last encounter is March 3rd, 2033. So we'll be going for a long time, which is a long time for somebody with my gray beard, particularly, right, when we're done. But we're going to go by 5 of these Trojan systems, right, for a total of 8 asteroids, because 2 of them we've learned had satellites. And one of the systems, which I must admit is my favorite, no, you're not supposed to have favorite children, but this is my favorite target, is something that we call a near equal mass binary. This is 2 objects that are about 100 kilometers in diameter, that are almost exactly the same size on a circular orbit around one another. And this one in particular, I think, dates back from the earliest times of solar system history, which is why I'm so interested in it.
So you flew by DINKINESH, one of the asteroids, a much bigger one. Tell me about that story.
Yeah, so DINKINESH is actually a really small asteroid. It's not part of the Trojan swarms. It's in what we call the main asteroid belt, which is the belt of asteroids between Mars and Jupiter. It just so happened we were going by very close. If we had done nothing to get there, we would have gotten within 64,000 kilometers of it. Think about it. That's about a fifth of the distance from here to the moon.
Absolutely.
So it was just a coincidence that we were getting close to it. And we decided that it would be a good test of our systems, right? So it was really a technological test, right? To fly by it, make sure the spacecraft was working, particular software on the spacecraft we were worried about. And this allowed us to test our systems before we get to our first Trojan asteroid in 2027. So we have plenty of time if we discovered something wrong to fix it, but the spacecraft worked spectacularly. Everything worked as it should, which is really good, right? And not only that, DINKINESH turned out to be a particularly interesting object.
In what sense?
It's interesting. Well, let me take a step back because I want to talk a little bit about where the name came from. We actually named the object DINKINESH. Most asteroids, particularly small ones like this, it's less than a kilometer in diameter, right, are unnamed. They just have numbers. And so we asked the International Astronomical Union to name it DINKINESH. Right, our mission is called Lucy, right? It's named after the fossil Lucy. We were trying to make the connection on how our mission is going to tell us about the history of the Earth and how we came about in a similar way that the Lucy fossil told us about the history of the human race, right? So we named the mission Lucy in honor of that. And so we decided when we were going to name the asteroid to name it DINKINESH, which, as you know, is the Ethiopian name for the Lucy fossil. So that's how that came about. DINKINESH ended up being really very interesting because it turns out that it had a satellite, which is not horribly surprising. But what was surprising is that satellite is actually a contact binary. It's two moons that somehow came together and touched, and now are actually in contact with each other physically. But you can see they were originally two almost equal mass things that came together, and that we've never seen before. And that is telling us, I think, something very fundamental about the building blocks of these small asteroids.
So when you mean the satellite, you're talking about the smallest asteroid next to DINKINESH, right?
That's right. And if you look at that, go ahead.
And you named it Selam, right?
We named it Selam after the fossil of the same species as Lucy, right? It was it died when it was about 3 years old. The nickname for this fossil is Lucy's baby. So we thought that DINKINESH and Selam together would be a good idea. So we named it Selam. And again, that has now been approved by the International Astronomical Union, which is how we come up with the name. So that's its official name at this point.
So when did you flew by this satellite asteroid?
The encounter was on November 1st. And one of the things about this encounter that made it particularly challenging for the spacecraft is that the satellite itself is so small. Like I said, it's less than a kilometer, about 800 meters in diameter. Each of the lobes, as we call it, of Selam are about 120 meters, so this is small. All the data, all those pictures, everything that you've seen, all was collected within about 15 minutes of the encounter. So that's another challenge, right?
Is that unusual?
It is, in that when we get to the Trojans, it'll be a couple hours that will collect data. But because DINKINESH is so small, it was a shorter period of time. But this is one of the challenges we are faced with these long-term missions, particularly if you're going to a lot of targets like Lucy is. We're going to more asteroid targets than any other spacecraft in history, for example, total of 11. We also are going further from the sun on solar panel power than any other spacecraft in history. But, you know, in order to cover the real estate that we're covering, we have to be moving really fast. So our encounters have velocities, relative velocities between about 6 and 9 kilometers a second. So as we fly by, we can't blink. We can't go back if we're making a mistake, right? You know, dynamics won't let us do that. So as a result, we have to be prepared, which is why we're testing everything, right? And we only collect data over the entire 12-year mission for a total of about 24 hours. The rest of the time is just traveling between the bodies.
So why did you, name this DINKINESH and SELAM, and even Lucy for that matter, the space mission? Because there are other fossils discovered in the last several years, the last 50, 60 years.
Yeah, well, in the United States, Lucy sort of has this this acknowledgement. Most Americans have heard of the Lucy fossil, right? I don't know why it is so popular here, but it definitely is, right? And so if you want to make that connection in a way, the connection, as I said before, between both the Lucy fossil and the Lucy mission telling us where we came from, right? Coming up with a name that is recognizable to most Americans seemed to make a lot of sense to us, which is why we chose it.
This mission, the Lucy mission, is divided into 6 phases. Is that correct?
Those are NASA phases.
Yeah.
Yes. So NASA missions are typically divided into phases. Phases A through D are development phases, right? Different phases of designing, building, and planning the mission. You launch at the end of phase D, and we're now in phase E, which is the science and operations phase. That will end a year after our last encounter, which I said is in March of 2033. And then F is just shutting everything down if that's what NASA decides to do, right? A lot of missions like Lucy have extended missions, right? Which means that they send the spacecraft to do something else if it's healthy. I think that's likely to happen with Lucy, but I'll be retired by then, so it'll be somebody else's problem.
So it's interesting, definitely. So it's going to be left to wonder.
If nothing happens to Lucy, yeah, one of the things that we did is if nothing happens to Lucy and NASA doesn't send it someplace else, it's going to be put on an orbit at the end of the mission that is stable for an average of 2 million years. So what we decided to do is we have a plaque on Lucy, which is messages by cultural leaders from all over the world to our descendants. NASA has previously put plaques on, and other things, on its missions to interstellar space as messages to other cultures that may stumble across it sometime in the future. Lucy is not leaving the solar system for something like 2 million years. So what we decided to do is you could easily imagine that our descendants, 500 years from now, 1,000 years from now, 10,000 years from now, are flying around the solar system, picking up our space junk to try to learn about our culture and our world, right? And so what we decided to do is there is a plaque on Lucy. We reached out to Nobel laureates. We reached out to, the Beatles are all represented, right? Things like that to give positive messages to our descendants. There's also a part of the plaque which shows the orbits of the planets on the day that Lucy was launched, right? And from that, anybody who finds it should be able to figure out when Lucy was launched. So we've tried to leave some clues as to what we were thinking and at the time we launched.
What is the reaction like from the public? How is it received? I mean, your space mission.
Well, this DINKINESH was our first encounter, right? So people were aware of, we made some news when we launched. We had a problem with our solar arrays, which also created some news. That was shortly after launch. I think we got a lot of positive press and a lot of good reactions. Again, we discovered something that no one ever expected before. These contact satellite. We knew there were contact asteroids themselves, which looked like two things that were stuck together. But seeing it as a satellite of a third body really was something no one expected. And that generated a lot of interest in the public, but also a lot of interest in the scientific community, right? People were just totally blown away.
Yeah, the world of astronomy is very exciting, is it not?
Well, look, I wanted to be an astronomer since I was 12 years old. And so it's been my focus for a lot of my life. I find it extremely exciting, right? I like the idea of trying to work out, again, my interest scientifically is about formation, right? How did we get here? And why did we get here? I mean, scientifically, why, right? And the processes involved. So I've always been interested in astronomy, geology, right? Paleontology, right? All those things are related to answering that question. I just happened to choose astronomy when I was young to work on. And even within astronomy, the origin of the universe, the origin of galaxies, the origin of solar systems are all something that I'm interested in.
What would you tell people, young people who would want to be astronomers?
I would say, first of all, you need to study physics, right? First, right? Everything that astronomy does, or at least the parts of astronomy I'm interested in, is based on physics. So learn your math, learn your physics before you decide what to do. The other piece of advice that I give young people starting out in the field is make sure you like the day-to-day activities, right? Just liking the results is not good enough, right? Because it's very rare that something like our encounter happens and you get all this new scientific information. Most of it is the work you need to put into getting there, right? And so while you may like looking at the pictures and learning about the geology or the history of an object like DINKINESH, you have to enjoy the engineering, or you have to enjoy the data reduction, or you have to enjoy the modeling. So make sure you enjoy the day-to-day stuff, right? And the really, really cool stuff will follow, because in any field, right, the day-to-day stuff can be a little tedious.
Thank you very much for joining me to talk about your space mission. It was really a pleasure being on my show.
It was my pleasure.